Good morning everyone. Myself SAJAL SASMAL, Assistant Professor in Electronics and Communication Engineering Department. I am going to introduce a topic, Z transform. So Z transform is a complex frequency domain transform, and so one question can arise that why frequency domain? Because calculation, analysis, synthesis are very easy in frequency domain. And another advantage of a Z transform, that is in Z domain, convolution of two time domain signal is equivalent to multiplication of their corresponding Z transform. That means if you want to find the convolution of a two time domain signal, suppose discrete time domain signal, then you have to use method of graphical or tabular or matrix method. But in frequency domain, at first you have to find out the Z transform of both signal and just multiply them, then you will get the convolution. So here is the definition of a Z transform. Suppose Xn is the discrete signal and you have to find out the Z transform of Xn. It is denoted as Xz equal to n equal to minus infinite to infinite Xn z to the power minus n. Here n is the range of Xn. So we can say Xz equal to x0, here n is 0, into z to the power 0 plus, if n equal to 1, then it will be x1 z to the power minus 1, n equal to 2, then it will be x2 z to the power minus 2, and so on. K may be 10 to infinite for a infinite duration sequence, or it may be a finite for a finite duration sequence. So now we will find some Z transform of some basic signals like del n. Del n, if you draw the impulse, then you will find that at 0 the value is 1, and for others value of n the value is 0. So the Z transform will be 1. That means x0 is 1, 1 into z to the power 0, that is also 1, so it will be 1, and the others value of x1, x2, x3 are 0, so the Z transform will be 1 for a delta function. And if the delta function or the impulse is delayed, that means delayed impulse. Suppose the impulse is delayed by 2 steps, that means del of n minus 2. So if you draw the signal, then you will find that at 2 the value is 1, or for other values of n the value is 0. So the Z transform of del of n minus 2 will be 1 by z square. How? Because x0 is 0, so 0, x1 is also 0, and x2 is 1 into z to the power minus 2, so it will become 1 by z square. If you consider any xn, xn means a discrete signal, then you can write it as a x0, comma x1, x2, the samples of xn. That is the value of n 0, 1, 2, so on, shifted by n step. If you shift the xn signal by n step, then you can write x of n minus n. So n minus n. So the signal will become 0, 0, 0. After n step, x0 will arrive, and then the normal sequence x1, x2, x3, and so on. So what will be the Z transform of x of n minus n? Then it will be 0 plus 0 plus 0. After n step, the x0 into z to the power minus n plus x0 into z to the power minus n minus 1, x2 into z to the power minus n minus 2, and so on. So if you do the calculation, then you will find that it will be z to the power minus n plus the z transform of xz. That means xz. So z transform of z x n minus 1 will be z to the power minus n into xz. So xz is multiplied by z to the power minus n if there is a shift of n step. So now we will go for the relation between z transform and Fourier transform. So suppose there is a discrete signal xn. So what will be the z transform of xn? Xz is n minus infinite to infinite, xn z to the power minus n. In polar form, at first I told you z transform is a complex frequency domain transform. So in polar form, the value of z is r e to the power j omega. So here is a complex part, complex frequency domain. Omega is the frequency part, and r is the radius of the complex j plane. So if you put r equal z equal to r e to the power j omega, then it will become x r e to the power j omega n equal to minus infinite to infinite x n r e to the power j omega to the power minus n. So if r equal to 1, then it will be x e to the power j omega n equal to minus infinite to infinite x n e to the power minus j omega n. And x e to the power j omega equal to n equal to minus infinite to infinite x n e to the power minus j omega n. It will become Fourier transform. So what we will find that z transform at unit radius, if the radius of the complex z plane r equal to 1, then it will become Fourier transform, means discrete Fourier transform. Next, we will find z transform of unit step signal. Unit step signal un is denoted as all the values are 1 starting from 0. 0 means the value of n is 0, and for n equal to 0 the value is 1, n equal to 1 value is 1, and so on. So z transform of un will be 1 plus z inverse plus z to the power minus 2, because the value are 1. Value of un at all the samples are 1. That's why the z transform become 1 by 1 minus z inverse. For GP series, you can write these things if z inverse is less than 1, so mod z will be greater than 1. Any exponential sequence denoted as c to the power n, the samples will be 1, c, c square, c cube. Here the value of n is 0, here is 1, here is 2, 3, and so on. So z transform of the exponential sequence z of c to the power n will be 1 plus c z inverse plus c square z to the power minus 2 c cube z to the power minus 3, and so on. So the z transform will become 1 by 1 minus c z inverse. And if the value of c is less than 1, then it will be a decaying exponential. That means the maximum value will be 1 at n equal to 0, and then the value will decrease simultaneously. And we can write this z transform if cz mod cz inverse is less than 1, that means mod z greater than c. Now suppose any z transform xz equal to 1 by 1 minus 0.8 z inverse. You have to find the inverse z transform. That means find the signal in discrete time domain from frequency domain or complex frequency domain. So if you compare the z transform with previous one, the general form of a general form of the Z transform of exponential sequence, then you will find the value of C is 0.8. So the discrete signal is C to the power n, that means 0.8 to the power n. That means C to the power n will be, when n equal to 0, then it will be 1, n equal to 1, that means 0.8, 0.64, and so on. So if you draw the signal, it will become 1 at 0, 0.8 at 1, 0.64 at 2, and so on. Next, suppose the Z transform is given as 1 by 1 plus 0.8 Z inverse. So yes, you will be minus 0.8, that means the signal will be minus 0.8 to the power n. So the value of the signal will be like this, and if you draw the signal, then at 0 the value will be 1, but at 1 the amplitude will be become minus 8, so it will alternate the value. And similar way, if you find the inverse Z transform of Z to the power minus 2 by 1 plus 0.8 Z inverse, then everything will be similar to the previous one, but there will be a seat of 2 step. Okay, so now you can find the inverse Z transform of 1 by 1 minus Z inverse. So the value of C will be minus 1 and the signal will be like this. So if you determine the Z transform and ROC of a signal, that is a infinite duration sequence, also a causal signal, xn is a to the power n un, then we know the formula of Z transform, xz equal to n equal to minus infinite to infinite, xn z to the power minus n, and as because it is a unit step signal, so the range will be n equal to 0 to infinite, and the Z transform of the signal will be 1 by 1 minus az inverse. So here the ROC of region of convergence mod Z will be greater than A. So what do you mean by ROC? ROC means region of convergence, that means where xz is valid for the values of Z, that is the ROC. So here is a sequence which is a anti-causal sequence, minus e to the power n u of minus n minus 1. If you find the Z transform, here you can say that the range which is minus infinite to minus 1, minus infinite to minus 1, the range will be minus infinite to minus 1. So the Z transform of the signal, if you change the limit, then it will become A inverse Z, and the Z transform of xz will be 1 by 1 minus Az inverse. So ROC will be mod Z less than A. Mod Z less than A. So here you can say that mod Z less than A, here is the ROC, imaginary axis, imaginary value of Z, real value of Z. So here you can say it is a stable, it is a stable system, because we will find that if the ROC lies under unit circle, then the system will be stable. Okay. So here suppose xn is the input, hn is the impulse response of a system, then yn is the xn convolution of hn, but in case of a Z transform, xz, az, yz is just the multiplication of xz and az, and there are some methods of inverse Z transform, that is residue method, or the contour integration method, or and another one is partial fraction method, and power series expansion method